My name is Nisha Tasneem. I'm from 11th standard. And sir, my question is quite insignificant compared to whatever you know. We don't have very much knowledge about dimensions. We're just learning very basic things about 1D, 2D, and 3D. But there are around 26 dimensions, or maybe 20. I am not much.
Yeah, I can.
I just wanted a little brief about what are dimensions. Like from 4D onwards, like we know about the x, y, and z axis of 3D. So when it will be 4D, what is the extra axis that will come? And just a little briefing about dimensions and all.
Of course. So let's say I pick up this tissue box right over here. So then this tissue box looks like this, right? So we've got this tissue box looks like this. And of course, I'm the best artist in generation, so you can obviously tell this is a tissue box. So this is the length, this is the width, and this is the height. All we mean by 3 dimensions is 3 metrics that we use to specify the size of any object. So, using the length, width, and height, we can say that this object has some sort of size. And the reason we use them perpendicularly is very simple. It makes our volume and area calculations very easy. So if we have a sheet of paper, usually the thickness is negligible. So we talk about the 2 metrics that we measure it with. We measure it via the width and via the height. And so if we're in 4 dimensions, then we use 4 metrics to measure it. But of course, we haven't come across any objects that need that in the real world. And so since we don't need it in the real world, we can't imagine what it would look like on a sheet of paper or a smartboard. It's a very nice question. And actually, the reason I said, what if we're in the 27th dimension, which apparently seems a little bit confusing, this essentially just means that we have an object that needs 27 perpendicular axes to measure. Of course, there's nothing like that in real life, and there probably never will be. But this allows us to generalize any vector, because the vectors that we have in our life usually have 2 components or maybe 3 components. But it turns out in general relativity, most vectors have 4 components because they have to account for time. And if we were doing general relativity in any other dimension, which seems to be useful for other applications like string theory, we could have even more than 4 dimensions, maybe even 12. So, we just generalize any vector because it makes things easier for us to do in higher dimensions, which we often need to do when considering theories that utilize higher dimensions. Of course, we already can see 3D in real life, but when it comes to 4D, which is what general relativity often uses, we can't actually visualize that. So we simply have to generalize it. When it comes to, for example, string theory, which has 11 dimensions, or so I've heard, then we need to generalize that even more because that is beyond human imagination. And finally, when it comes to the axis that is beyond x, y, and z in 4th dimensions, doesn't have an official name, and any official name isn't important, but most people opt to call it W. So thank you for the question. It's very interesting.
Thank you, sir.
Thank you.